The research that we did was part of a broader study on climate-appropriate HVAC technologies that we conducted for Southern California Edison. And my team's contribution was to investigate the market barriers to climate-appropriate HVAC technologies that they faced within California's small and medium-sized commercial buildings, with a particular focus on opportunities to increase supply chain adoption. We used two specific retrofit technologies as case studies: an evaporative pre-cooling condenser air retrofit and a retrofit supply fan speed. The fact that these things have like 16 descriptors in front of them may be a problem. But we're keeping them anonymous for obvious reasons. So while I focus specifically on these retrofit technologies, I think the findings are more broadly applicable to HVAC technologies in general. And so I'm going to highlight what I think is most broadly applicable. In exploratory research such as this, we're trying to answer the questions who, what, when, where, why, and how. We're on a quest for discovery, and so our methods lean towards more open-ended techniques. We use mixed methods for collecting data, including in-depth interviews, group discussions, and online surveys. We collected data from 76 participants as well as countless others from each of the stakeholder groups listed here. Then we transcribed the group discussions and the interviews and analyzed the content using grounded theory, whereby you allow the salient themes and findings to emerge from the data, as opposed to starting from a particular hypothesis and then looking to see whether the data proves or disproves. And this is a common technique when you're really trying to figure out what's going on. So first we think about who does what. You're probably familiar with the typical supply chain for HVAC. There are variations to it, but this is a simplified version. Manufacturers sell to distributors, who sell to contractors, who sell to consumers, and the utility is kind of off on the side, perhaps offering a rebate at some point along the supply chain. But note that actually there's a preliminary step that each stakeholder group has to take, and that's to decide to carry these technologies, to adopt them, and to promote them. And so that's really the action that we research. So the next question was, why do stakeholders decide to buy and sell, adopt, or promote ET? From behavioral theory, we knew that the responses would fall into two broad categories: motivation and ability. So we used a model of behavior change developed by Stanford professor B.J. Fogg to guide us. This model explains that with respect to any particular action, in this case adoption of an ET, people have certain motivations which relate to their needs, their wants, beliefs, preferences, incentives, and certain abilities. And that relates to the time, cost, effort, knowledge, and feasibility of a particular action. Now there's a threshold under which no action is taken, and that's all the area under the blue curve, right? There's simply not enough motivation or ability to take an action. And the theory goes that once you get close enough to that line, some small thing can trigger action. We call it a nudge generally. And we've covered that in our project report, but the truth of the matter is that most stakeholders are so far from that line right now that I'm not going to talk about it in the discussion today. But this model is helpful because it makes clear, first of all, that there's an infinite combination of high and low motivation and ability, and it reminds us that it's likely that stakeholders face numerous barriers, not a single one. And furthermore, that for each person or entity involved, they may face a combination of barriers. And so what this means is that our research approach needs to be able to capture this nuance, and so that's what we aim to develop. Our research identified 8 factors affecting stakeholders' motivation to adopt ET. Some of them are obvious and were well known going in, like high initial cost. But our research approach yielded some more subtle factors that impede adoption as well. And I've listed all 8 here, but I'll highlight a few of them in more detail. First, in some customer organizations, the person who can make large capital improvements has no incentive to do so, because he's not responsible for the electricity bill. So any energy and cost savings that accrues doesn't go to him. And as a result, you sort of divorce the ability and the motivation to adopt the technology. And most likely, there's a person in the organization that has the reverse. They have the incentive, but not the ability to do it. Secondly, although the technology's main selling point is energy savings, many stakeholders told us that they actually have more success by promoting the technology's other benefits, these sort of qualitative features, like visibility into how their HVAC system is working. But what each customer values is different. Respondents told us, and we heard this from another speaker, that hospitals care a lot about reliability. For office environments, the priority is air quality and comfort. We heard that high-tech firms, some seem to like to have the latest and greatest technology, not because of energy savings, but because they have their reputation as a high-tech firm. So they even want their HVAC to be high-tech. Some contractors told us that they themselves like to carry the most progressive technology because it helps them distinguish themselves from other contractors in the field. So it's important to tailor the pitch to particularly what's motivating that stakeholder. And we need to consider the fact that although we consider energy savings as the primary motivation, that may not in fact be true for the stakeholder involved. And third, we learned that endorsements are important, but more specifically, it matters who is recommending the technology and how much that party is trusted. Respondents seem to most value recommendations from utilities, from reputable third parties such as universities and the DOE, and from other colleagues who've had personal experience with the technology. Personal experience came up over and over and over again as being very important. So more efforts are needed to facilitate and leverage endorsements by trusted entities. Our research also identified 6 factors affecting stakeholders' ability to adopt technologies. And again, it's a mix of well-known barriers and some more subtle ones. All 6 of them are listed here. And again, I'll highlight just 3 of them. So although we knew going in that cost is a barrier, we learned that uncertainty about cost makes adoption difficult. Many stakeholders told us that their customers worry they won't actually get the rebate that's promised to them, and as a result, they can't adopt the technology. Now, digging a little further, we found that this risk probably is unfounded, but utilities can't afford to ignore this because a perceived risk is as detrimental as a real one if it constitutes a barrier to adoption. Next, looking at effort. Unfamiliar technology is harder to sell, and anything that takes more effort on the part of anyone involved constitutes a market barrier. So distributors and contractors are rationally going to promote conventional technology when it takes less time and effort for them to close the deal. One way to address this is to provide more support to them to make the sales process easier. Some have had success by putting together demonstrations where they can do sort of a hands-on experience. Videos, like we saw earlier with Aeroseal, that was very powerful. And testimonials, where there's sort of a peer-to-peer information sharing component going on. By using any of these mechanisms, you can make the sales process easier and minimize this particular disadvantage that emerging technology has relative to conventional ones. So on the margin, if a distributor is trying to decide, or a contractor is trying to decide, am I going to recommend this one or this one, you sort of help get the balance in favor of the EC. And finally, looking at empowerment, this is the idea of whether stakeholders can adopt or promote the technology. There's a lot of people who need to buy into a technology in order to adopt it, even within a single organization. For example, at design engineering firms, the principals may officially adopt a technology at the firm level, but if the engineers who create the designs on a day-to-day basis don't specify those EPs, then they haven't really been adopted in any meaningful sense, right? Because of the nature of the supply chain, if it doesn't get specified, it doesn't make it down to the next level. Similar issue exists with distributors. We heard about CEOs of distributors going to trade shows and learning about great new equipment, deciding to carry it, maybe even convincing regional offices to carry it themselves. But then we were told that ultimately it's sort of up to the discretion of an individual salesperson whether they pitch it or not, and there's some variation within a given office. So in cases like this where the power to adopt and promote technology really lie at 2 different levels within an organization, you need to get buy-in at both levels. Okay, so So in addition to the 14 factors that I showed on previous slides, which are listed across the top relating to motivation and ability, we also found 5 cross-cutting themes that emerged which interact with these factors and affect all stakeholders. The first is dependency. Retrofit technologies depend on existing HVAC equipment to function, period, right? That has introduces its own set of complications technically. But in addition, supply chain actors depend on the decisions of one another, right? A distributor can't sell to his customer what he can't buy from his distributor. So this makes things complicated, but it also means that if you can find solutions for encouraging coordination and building broad support at the outset, you can leverage this interdependency to have spillover effects. The second is risk. Now, there are obvious ones. Technical and performance risk is often cited, so is financial risk. But respondents also talked about more subtle things like reputational risk. Distributors and contractors didn't want to risk losing their customers by promoting an equipment they really didn't fully trust yet. In addition, as I mentioned earlier, many perceive that there's a risk of not receiving a utility rebate. Although they didn't believe that this would actually come about, one design engineering firm we interviewed decided to address this by assuming that responsibility themselves. So they have the customer write the rebate over to them. They take full responsibility for filling out all the paperwork, and they assume all rebate risk. Now, if we think back to the factors that I talked about earlier, this actually does many things all at once. It reduces the cost uncertainty and the effort required on customers. So that takes care of 2 market barriers. It also serves as a strong endorsement, right? Because by taking on the rebate risk, that design firm is signaling that there's actually no risk at all, either with the technology or with the rebate. And that can have a powerful effect in raising motivation and ability. So I would argue that even if customers don't take them up on that offer, the fact that the offer exists sends a very strong signal that they should, that they can trust that this is not anything to worry about. So again, more efforts like this to mitigate risk, both real and imagined, are encouraged. Next is opaqueness. There's opaqueness about costs, responsibilities, expectations, and requirements, both of the technology and the people involved. Anything that increases transparency is helpful. One of the technologies we studied has a mechanism to provide data on its performance in real time. Now, of course, there's direct value in this, but it has these indirect values in that it provides transparency, which signals that the technology can be trusted. It literally has nothing to hide. You can see how it's working, when it's working, and you can see when it's not working. This is very compelling when promoting the technology, both to customers and to other stakeholders. And other manufacturers would be wise to try to incorporate this function into their technology as well. Fourth is accountability. People need clarity about who's responsible for what and what recourse is available if something goes wrong. Stakeholders need to coordinate in order to ensure that their roles are clear at the outset. And fourth is trust. When taking the leap to adopt a new technology, building trust in the technology as well as the people involved is important. And by people, I mean the individuals and the organizations involved in recommending, selling, installing, and maintaining the technology. Giving stakeholders the opportunity to see the technology themselves and to talk to their peers that have worked with it has been a successful strategy in the past for building trust, and further efforts like this are needed. Several key conclusions emerged from our study, and I'll highlight 3 of them here. The first is that information plays a vital role. Now, of course, this was obvious going in, but we learned some important details. Stakeholders need several different types of information. They need technical details, they need financial details. There are lots of sources of information that stakeholders use, including each other. Lots of peer-to-peer information sharing when they find a gap in information available through more formal channels. Information needs to come from a trusted source, and it needs to reach the precise individual who requires it. So the facilities person needs the technical details, and the financial person needs the numbers. By understanding precisely what information is needed and from whom, the industry can address some of these market barriers. Next, looking at a simple cost-benefit analysis of the technology from a behavioral perspective reveals an obvious problem. That is, while the initial costs may be certain, known, and immediate upon purchase, the benefits, that is, the savings that are intended to offset these costs, may be uncertain, delayed, and hard to verify. Under these conditions, it's very difficult to convince stakeholders to adopt emerging technologies on the grounds of long-term cost savings, because the benefits are heavily discounted in the minds of stakeholders. This is a classic example of what behavioral economists call an intertemporal choice problem, where you have all the negative stuff uploaded up front and all the positive stuff way off in the distance. We tend to discount what's coming in the future, and so it manipulates this balance. So what can we do about it? We can't hasten the accrual of benefits, right? Energy savings accumulates at the rate that it does. But we can use some of these research findings to address the uncertainty and the opacity or the lack of transparency of the benefits. For example, manufacturers can incorporate in their technology software that tracks technical performance, energy use, and energy savings. Stakeholders can then develop software that translates those energy savings into cost savings. And then finally, track progress towards recovery of your initial investment. Remember that these technologies are often sold on the virtue of cost savings, right? They're promised payback in 5 years or 2 years or 6 months. But it's rare that there's actually an easy mechanism to monitor whether that happens. Stakeholders told us that it would be a really powerful selling point if people could track progress towards that payback. So they could verify whether the way it's working out matches with what they were told. Now again, it doesn't have to be perfect. It needs to be within some boundaries. But up front, this builds a kind of trust. Again, this type of tool would provide information, transparency, and accountability. It would build trust and reduce perceived risk, thereby increasing the motivation and ability to adopt the technology and hopefully put the balance back in favor of those perceived benefits by addressing some of the issues involved. And finally, the research identified subtleties in the market barriers that stakeholders face. For example, the high cost of EP is often cited as a major market barrier. But is the issue really cost itself? If so, offering a greater rebate might help. But instead, many told us that the problem actually is the lack of information about costs. In that case, adding more rebate is not the answer. Instead, more information is needed about project finance, particularly the ongoing costs and maintenance costs. Or in fact, is it uncertainty about the costs, as some respondents suggested? If better information were available and uncertainty about costs was reduced, perhaps those initial costs would be more palatable. If we can pinpoint what the precise issue is for each stakeholder, or better yet, create a mechanism that can do that for us, we can develop ways to target the specific impediments by offering rebates, information, or guarantees as appropriate. In addition, we can use the lessons of this research to design interventions that leverage multiple forms of motivation and ability to adopt EP. For example, on the face of it, utility rebate programs merely increase the ability to adopt or sell an emerging technology by reducing their costs. But actually, they do so much more than that. They constitute an endorsement by a trusted party. They're a mechanism for providing information from a trusted source. When viewed through this lens, we can see that utilities actually have several mechanisms that they can utilize to encourage adoption. And numerous stakeholders told us that they would find it useful if utilities leverage that influence further. In particular, to deal with some of the market barriers that we identified. They had ideas like putting together some sort of training material for addressing best practices on how to deal with stakeholder coordination, how to get everybody in the room that needs to buy into the project, and how to mitigate the risks that people perceive. It just so happens that our next phase of work for SCE is going to deal with exactly some of these things, identifying what these best practices are, and then figuring out how to create around that. So to conclude, I want to put in a plug for the behavioral work we do by highlighting the value that comes from widening our lens beyond the narrow economic perspective on market barriers. When we recognize the fact that each stakeholder organization, utilities, manufacturers, distributors, contractors, customers, everyone, is comprised of individuals, we can apply behavioral science to understand what's driving their decision-making and to identify many opportunities to raise motivation and ability to adopt EP, and in turn, stimulate technology diffusion and hopefully energy savings. So that was just a very brief overview of a very long project report that is available on our website and also on the ETCC website, hopefully in a forthcoming paper within the next year. And if you have further questions, I hope you'll check out the report, ask me, or talk to me or Jonathan later on today.